Hey guys, this is the extra practice video on capacitors. I'm using as the first page the additional problem, which you should be able to find in your Googly Drive, about designing a new capacitor for an AED. Um, Regardless, before we do the actual example, I wanted to begin with a little bit of a quiz. The purpose of this quiz is to help you identify when you're looking at one of these problems, like, what is this number? Where do I put it into an equation? And what are they asking me for? And okay, so all the things where you're supposed to like figure out what's the key word that tells me what I'm looking for, right? What is the letter for the thing? What are the units for the thing? And that's a reading comprehension skill, all right? But essentially, if you know where to put the number, that's going to take you a long way through any of these questions. Capacitor questions really are a lot of plug and chug. So if you know what kind of a number 0.267 square meters is, well, you know where to put that in, and that gives you a big hint as to which equations you should probably be using. All right, now here's the first question. As you can see, there's a lot of answer choices. So rather than me like pause for 10 seconds per problem or something, and then that takes a lot of time that you'd have to like fast forward through, what I will do is I will go to it, pause for long enough for you to think about pausing it yourself, okay? And then I will circle the correct answer and maybe explain it if I feel it necessary. Okay, so when I go to the next question, you immediately hit the pause button, and then when you think you know the answer, you resume, and I will tell you the right answer. All right, let me shut up. Y'all think about it, pause it. What the heck is that? Okay, 2 times 10 to the negative 6 C. C is for coulombs. And that would be a charge. All right, on to the next question. Remember to pause me. F is for farads, which is the unit of capacitance. The reason I put these two questions back to back is because sometimes people think that C, which is for coulombs, is for capacitance, and so they get a little mixed up there. All right, I'm going to the next question. Pause me any moment now. You really should remember newtons per coulomb from the previous unit, for behold, that is the unit for electric field. All right, next question. So you should remember from earlier in this unit that volts per meter is another unit for electric field. But why are there 2 units for electric field, Mr. Erico? I don't know. There's many different units for many different things. So because there's more than one unit, you ought to know both units just in case. This one really should be easy because, after all, V is actually for volts. There you go. Now, the answer choice here says potential / voltage. I do want you guys to know that potential is a synonym for voltage because actually potential really is the more formal physics term. Voltage is less formal but is used plenty. So you ought to know volts is the unit for potential, often called voltage. Just seeing if you're paying attention. Farads is still for capacitance, even if it's microfarads. But you do need to know that micro means 10 to the negative 6th. So don't forget about that one. And J is for joules, which is the unit of energy. That's right. Good job. Now, probably in this question, you'd be able, it wouldn't just be 0.12 centimeters without any context, right? You'd have a little bit of information that should indicate to you like how far apart the plates are is what that number is. But since that's just centimeters, that's going to be plate separation. Now, you got to be careful, remember, centimeters is not okay to plug in directly. You'd have to convert that to meters. So I guess further quiz, you can pause me again. What would that be in meters? And that's right, it's 0.0012 meters. Centi is 100, so that means you're moving 2 decimal places. Yes, square meters is in fact surface area. Important vocabulary term that people have been saying the last couple homeworks they're really confused about is, what is dielectric strength? Oh my gosh. Dielectric strength is electric field, which anytime they tell you the dielectric strength, you should be able to tell what it is because they'll tell you units of newtons per coulomb or volts per meter. A little more tricky is if they say, calculate the dielectric strength. And if you don't know that a dielectric strength is an electric field, you won't know how to calculate it. All right, so you got to know dielectric strength is electric field. More specifically, though, dielectric strength is the maximum electric field. Just because a problem asks you to calculate the electric field does not mean that you're calculating the dielectric strength. Okay, so it's only the maximum electric field is the dielectric strength. Obviously, you can have a electric field which is less than the dielectric strength, and that would be if you are not at, say, the maximum volts or charge or whatever it is. All right, so for this one, the format here is a little bit different. What I want you to do is, with each of those numbers in blue in the middle, you're going to draw an imaginary arrow or whatever to show where to plug that into each equation. So, for example, if you thought that 2 microfarads was the area, you would go and draw to the A. Okay, that's not right. Don't do that. All right, so pause it, draw arrows to each of the various equations where you think it would go. Okay, so if I really did think that 2 microfarads was area, I'd draw 2 arrows. Yeah, that's all the A's. All right, but again, that's wrong. So don't do that. Great, so pause and draw all the arrows, whether real or imaginary. There, I hope that is not too confusing. Many arrows. Okay, next one. And there we go. All them arrows too. All right, now beginning with the next slide, we're going to do the actual worksheet problem. So have that in front of you. Maybe a physical copy would be easiest. So practicing the skills that we were developing during the last few minutes, what we're going to do first is read this problem through and figure out for each question what the thing is that they have given us, and also what is the thing that they are asking for. Right? So for each of the questions, what you should do is, again, pause me as usual, identify each number for what it is. All right? Is that value a surface area? Is that value an electric field? Is that a whatever it is? Okay, so pause me and then go through and for each question identify what is each of those numbers and what thing are they asking to solve for. All right, now based on your very close reading of the text, you should have been able to identify the capacitance, very first number they gave you, and that this AED is supposed to operate at 220 volts, which hopefully is enough to restart your heart. Now, the quantity they want you to calculate is energy. E is not for energy. E is for electric field in this unit. So that means you're solving for U, which is in fact for energy. All right, so next step is find the equation that you're supposed to use. Based on the things that we have calculated so far, 1/2 CV squared would be the right one to use, and there's our answer. Now, before I go on and start showing you how to do part B, you try and solve it on your own based on what you think they're asking you to calculate and the information that you now know we have. So identify the thing they want you to find an equation that will solve it. That's right, we are solving for charge, which is Q. And C equals Q over V is the very equation that can give us our answer of, holy cow, that is 1/10 of a lightning bolt. That's a pretty big shock right there. Whew. All right. So again, pause me before I work out part C if you're not there yet. See what you can figure out on your own. So this one is probably the trickiest, I would say. The main problem being identifying the equation that you're supposed to use. So the thing they want you to find is the plate separation. And they tell you the area of the plates. I told you earlier that the kappa, the dielectric constant, is 233. So figure out what else you know of any of the things that are given on this page that would help you to solve for the distance. Honestly, you might come up with a more clever way of doing it, or at least a different way of doing it. I honestly don't care as long as you get to the right answer, which, by the way, is 1 times 10 to the negative 6th meters. So if you find some other way to get there besides what I do, that's okay. That's the goal, though, is get 1 times 10 to the negative 6 meters. So see what you can figure out before you just watch me do it. Now, I decided to use the capacitance equation that we have here, because I have everything else in there except for D. Now, be careful with the algebra. We're solving for the thing that's on the bottom. Often that is tricky for people, so be careful with the algebra. But it should just be plug and chug as long as you aren't sloppy with the algebra. Okay, plugging in. And the answer. We did it. All right, now part D wants us to calculate the maximum voltage that we can place on our AED. All right, now remember that word, maximum. If it says maximum voltage or charge or whatever it is, that's the key word that means you are looking at the dielectric strength, which is the maximum. Ooh, what is it? The maximum. That's right, it's the maximum electric field, and then everything else is based on that maximum electric field. So because the field has a maximum, everything else has some maximum value that corresponds to it based on one equation or the other. So here I have rewritten the 2 equations that might serve us well because they've got electric field in them. But based on what I'm trying to solve for, only one of them is useful. I wonder which one it could be. Frankly, the one on the left is my least favorite equation. I will only use it if I absolutely have to. And usually there's a workaround. I don't know. I don't like it because it's got a denominator and the numbers in it are annoying. I just hate working with that stupid epsilon naught number. So if I have to use that twice in one problem, I'm probably doing something wrong. But as it turns out, we don't need it because this is what I might use to calculate, say, the maximum charge. They could have asked that, but they asked for the maximum volts, which is much more straightforward. So plugging in the dielectric strength and the plate separation that we saw for in the previous part, we get that the maximum volts we can place on our AED is 8 volts. Yeah, but see now, I thought we needed 220 to shock someone's heart. But yes, you can't restart someone's heart with a mere 8 volts. Otherwise, a 9-volt battery would kill you. So, yeah. So that means that our design will not work. Okay, so that is the conclusion of Part D, is that we need a better design. Okay, now I hope that example was useful, but you know what? Feel free to make up your own examples and see if you can make everything work together, right? Pick a set of numbers that you are, quote, given, all right? And then plug them into the various equations and solve for the other stuff and make sure that the values come out self-consistent. And that would be, I think, valid practice. Also, practice for the quiz would be look over all of the previous problems that we've done in this unit. See if they make more sense now than they did when you first worked them out. All right, guys, that's all. I'll see you on the internet.